Today, we'll be solving LeetCode 98, validate binary search tree. In this problem, we are given the root of a binary tree, and our goal is to check whether the tree is a valid binary search tree. A valid binary search tree must follow two key rules. First, every node in the left subtree must have a value that is strictly less than the value of the current node. Second, every node in the right subtree must have a value that is strictly greater than the value of the current node. These rules must hold for every single node in the tree, not just for the root. The challenging part is that these conditions are not just between a node and its direct children, they must be enforced throughout the entire path. For example, if you are deep inside the left subtree, the values there still must be less than not only their parent but also the original root, if the root was greater. This means that as we move through the tree, we need to keep track of a valid range for the values we can accept. Let's think about how we can solve this. A natural approach is to use depth-first search, because we can start from the root and explore each branch all the way down, while carrying the allowed range for each node along the way. At the very beginning, the root can have any value, so our allowed range starts from -infinity to +infinity. As we go left, we will shrink the maximum allowed value, and as we go right, we will increase the minimum allowed value. Now let's go through the code step by step. We start by defining a function called isValidBst that takes the root of the tree as its input. Inside it, we define a helper function called dfs, short for depth-first search. This function takes three arguments: the current node we are looking at, the smallest value that is allowed for this node, and the largest value that is allowed for this node. Inside dfs, the very first thing we check is if the node is none. In other words, if we have reached past a leaf node. If that happens, we simply return true because reaching the end of a branch without breaking any rules means this branch is valid. Next, we check if the value of the current node is less than or equal to the smallest allowed value, or greater than or equal to the largest allowed value. If either of these conditions is true, it means the current node's value is not within the valid range for a binary search tree, so we immediately return false. If we pass this check, that means the current node's value is valid, and we now need to check both subtrees. To check the left subtree, we call dfs on the left child of the current node, keeping the same smallest value, but changing the largest allowed value to the value of the current node. This is because everything in the left subtree must be strictly smaller than the current node. To check the right subtree, we call dfs on the right child of the current node, but this time we set the smallest allowed value to the value of the current node, and keep the same largest allowed value. This is because everything in the right subtree must be strictly greater than the current node. We return true only if both the left and right subtree calls to dfs return true. Finally, in our main function, we start the process by calling dfs with the root node, a smallest allowed value of -infinity, and a largest allowed value of +infinity, because the root can initially be any value. The time complexity of this solution is O of n, because we visit each node exactly once. The space complexity is O of h, where h is the height of the tree, which comes from the recursion stack in our depth-first search. And that's how you solve LeetCode 98, validate binary search tree. Thank you for watching and let's keep learning.